question. Dictionary question comes up a lot, or even not the question itself, but how do I solve that problem? How do I keep track of what the question is asking for? So really knowing how to use the dictionary, right, is very, very important. So I'll go through that question, we'll go through the solution, and it's very important that we understand how to accomplish that task we do today, right? Because you're given a question, for example, the question will start, given an array of integers, create, well, I'm not going to say create. So given an array of integers, return a dictionary of occurrences of each integer. Right? Example input would be some array 1, 3, 1, 1, 3, 4, 1, 8, 2, 7, 8. Right? And our output could be, or will be, output, not in any particular order, because what do we know about dictionaries? They're unordered, correct? So the order we put here is not necessarily going to be the order that you get outputted. So here we'll put 7, 1. 7 appears once, right? So far so good? How many times does 1 appear? 4. 3. How many times does 3 appear? 2. How many times does 8 appear? That's it, right? Oh, we have 2 as well. How many times does 2 appear?
4.
Huh?
2 appears once, 4 appears once.
4 appears once. Okay, great. 4 appears once. All right. Do we all understand what the question is asking for? That's the most important thing. Number one, make sure you understand what the question is asking for. That particular question has, given this array, our input array, go through the array and return us a dictionary of how many times each integer appears in that array. Eric? Right? So we look at number one, and we go through our array and keep count of how many times do we see the number 1. Everybody with me? Right? We do 3. How many times do we see 3 here? We see it twice, correct? We see it once, we go through, we see it twice, right? So we got to keep track of that. Knowing how to do that is fundamental to using a dictionary, right? It could be this question, it could be return me some character, how many times does that character appear? Or does that character appear? How to do that and how to store that using a data structure of a dictionary is very, very important. Okay? So let's go ahead and solve that problem. So we're writing a function. Given an array of integers, return, well, write a function. Given an array of integers, write a function that returns a dictionary of occurrences of each integer. Okay. So Adam, what does our function start with? Our function, what does it start with? How do we? Okay, so we have func. Jahid, you want to give the function a name? Okay, so we'll say occurrences here of integer. Cool? What is the return type of our function, Jahid? The return type would be an int, you said. Let's read the question, all right? So returns a dictionary. Okay, so it's a dictionary of ints. So what type is the key? The key is int? It's a dictionary, right? So far, so good. So we have a dictionary here. We have the colon, right? What is the key? for the dictionary in that case? Zara? Yeah, 7 would be the key. So what data type is 7? What type is 7? What data type is 7? 7 in that case is an integer, right? So it's an integer. And if we keep in count of the integer, how do we keep count? What data type is a good data type for that? To keep count? An array. What else? What data type? Is it a string, a bool? Like, how can we keep count? We're counting from 1, 2, 3. How can we keep count of that? Like, what would be the value here? An int, right? According to Lydia, it would be an int, right? Because int, if you look at our output, our key is 7. 7 is an integer, correct? Our value is also an integer, right? How many times did we see the number 7, right? We keep count of that using an integer. So here, our output is a dictionary, right? Where the key is an integer and the value is an integer. Are we happy with that? Eric? Amini? Good? Okay. Kelby, how are we doing? Good? Okay. So the one, I'm sorry? Oh, you mean like the parents? Like this? Yeah, we haven't done the parameter. We're just doing the return type for now. We'll get to the parameter. Actually, you'll help us with the parameter. What goes into the parameter list? What's the input? What's the input of the function? So given an array of integers. Exactly. So there you go. Very good. So here we have an array of integers, right? The first part of solving the problem is trying to figure out what is the input of my function. In that case, what's the input of my function, Yulia? Array of integers. And Shania, what's the output of my function? A dictionary, right? Of a dictionary where the keys are ints and the values are ints. So far, so good. Okay, so here we have our function, we have a name, we have our parameter list, and we have our return type. Great, we could go into our function and start coding. Okay, great. So we need to create some sort of dictionary to store what we're looking at. Everybody with me? So here we'll create a variable. It has to be a variable. Why can't it be a constant? Because we're going to change. We're going to mutate it, right? So it needs to be a variable here. We'll call it frequency of, frequency dictionary here, shorten. And my type is a dictionary of ints, values. Great. Before we continue to do anything else, we want to have a return, right? Have a return, and we'll go ahead and do the logic. So here, we're returning our dictionary, right? Basically, what we're creating here is a frequency dictionary, right? How many times does a certain element appear? How many times does a certain element appear in an array or string or whatever input you have? To keep count of it, we create a frequency dictionary. That's why we actually call it, let's just call it frequency dictionary here. Spell out the whole thing. Number of what? If it's not, it should be. Not all the questions will come from the dictionary. Oh, okay. The reason why I'm doing that problem is for us to actually know how to solve, because that's a basic dictionary question. That actually comes up a lot. So here we'll say frequency, and also we're not memorizing, right?
No, I'm not.
Okay. Got it. All right, cool. Very good. So here we're creating a frequency dictionary. We want to see how many times a certain number appears in the array. How do we go through our array? Mr. Benvenido, how do we go through our array? A for loop. So what am I writing here? For number in in array, right? Great, thank you, sir. So now we're actually going through our array using a for loop. For loops are great. It goes through a collection. As long as that collection conforms to sequence and collection, we're good. So here we have for number in array according to Bienvenido. Now we're in the array, we want to do something. We want to see first if we saw that number before. If we saw the number before, what do we do, Mel? If we see the number before, what do we want to do? Yeah. It's okay. Like, for example, let's do it, right? So I saw number 1. What do I want to do? How do I keep track of number 1? Do what? Enumerating the array here? Yes. Well, that array doesn't have a way to keep track of the number. We have our dictionary here, our data structure. It's empty right now. The first time I see number 1, I want to go ahead and add it to our dictionary. Right? That's what we want to do. So here, let's add some notes. So first time visiting a number, we want to set the count of occurrences to 1. Does that make sense? The first time we see it, the number of times we saw it is 1. Everybody with me? Everybody with me? First time I see number 1, I saw it once. Okay? Next step. Next time we visit a number that appears in our dictionary, we want to what? What do we want to do here? Next time we visit a number, for example, the next time I see 1, what do I want to do to my count? Increase it by 1, right? Very good. So next time we want to increment by 1. Right? So here we actually wrote what we want to do, right? We're pseudocoding it somewhat. We're saying the first time we see a number, we want to set the count of occurrences to 1. The next time we see a number, we want to increment it. So far, so good. So how do we do that? A variable is good, but we have a data structure already. That's empty right now. All we have to do is access it and see if that number is part of that data structure already. And the dictionary is perfect for that. Let's go ahead and continue the code here. So here I will say if my dictionary, frequency dictionary, has the current number, in that case it's called number, right? Here we're using optional binding. We're saying if our frequency dictionary has the key, right? That key, right? For example, if we have, let me do it up here, it's better. So my frequency dictionary could look something like this. Frequency dictionary, accessing the key. The key here, for example, is 1, right? Everybody with me? We're accessing the dictionary with the key. In that case, the key is an integer. 1 is a valid integer. Everybody with me? Everybody with me? So here, if this frequency dictionary at 1 does exist, remember our dictionary when we access it returns an optional. Everybody with me? Right? When I say my dictionary key, what type is count? What type is count? Option click. What type is count? Tiffany? Is it just an, oh, it's an integer in that case because we've unwrapped it already. Right? Everybody with me? But if we go ahead and copy frequency dictionary number here, and let's see what type it is. So test type, for example. So go ahead and copy or frequency dictionary access number, in case not number, but 1. And tell me what test type, what type is test type? Adam, what type is test type? Cassandra? Okay, so Cassandra said test type is an optional integer. Do we agree? Do we agree? Ian? We do, right? Why? Because 1 might not exist in our dictionary. Does everybody see that? 1 might not exist. If we put 77 there, we do not have 77. Well, it's not there yet, period. So we don't have it. It's optional. It returns us an optional. In that case, because let's put optional here, so test type is an optional int. Great. In the case it doesn't exist, according to our notes here, first time visiting a number, we want to set the count of occurrences to 1. So this is actually, go ahead and copy your notes, where it says first time visiting, copy your notes. And the first time visiting is the else statement. Right? Because if count here doesn't have a value, that means I do not have it in my dictionary. Do we agree? Right? Anna, what happens in the else statement with optional binding? How do we get to the else statement if we try to unwrap a value? Why do we get to the else statement? Yeah? If the value is nil, right? So if the value is nil, we come to our else statement. In other words, if we try to unwrap our frequency dictionary, try to search for that number, it doesn't exist. Count is nil, right, everybody? It comes to the else statement. Do we agree? Greg? Oscar? All right, cool. So here, what we want to do is go ahead and assign it according to what we said there. Assign the count to 1. So we say frequency dictionary, number. The value gets set to 1. Remember, we assign a value on a dictionary with dictionary name, right? The key that we want to set and the value we want to set is on the right side of the equal sign. Kelby, question? Sure?
Yeah.
Okay.
Just,
I saw that.
I'm like many and think back to how I did mine.
Okay. All right. So here we have our dictionary number. We assign it to 1. Everybody with me? So example, in that case, our 1 would now have 1. Our key 1 would have count 1. Do we agree? Yes, sir. No. There could be, it doesn't, well, if you haven't seen it, the key doesn't exist, right? But if you have seen it, it's going to be at least 1, right? Yes, Tiffany?
Okay, so the test type equals frequency dictionary with 1. That has to stay there as well.
That was for testing purposes.
Okay, so it doesn't necessarily.
You could remove it if you feel okay with that. But the reason why I put it here, because we have to go ahead and optionally bind it in order to get the actual value. Because if we do not, then we have an optional here. I wanted to show you guys what the optional looks like if you do not unwrap it. Right? So if you option click on test type, it's an optional integer, correct? Correct? But if you go ahead and optionally bind it, unwrap the number, then our count is not an optional. Right? Our count is a regular integer using optional binding. Right? So again, this was for test purposes. Just remove it. You don't need that here. Okay? You don't need that here. That was for testing, for us to see what's going on. Okay? All right. Cool. So here we are using optional binding to unwrap the value at the given key in our frequency dictionary. Cool? So anytime you want to access the actual value, either you use nil coalescing or optional binding. Everybody with me? Remember, the key doesn't necessarily have to exist in that dictionary. Obviously, we have more numbers than the numbers we have there. If you try to unwrap 3, it's not there. So what do? You go to your else statement, and you add a count 1. Okay? Okay, cool. So here, we come in our else statement. If that's the first time we're visiting a number, if we come here, and our number is 1, right? Take a look at the input. If we come back and we see 1, in that case, the third case here, do we go to the else statement or do we go to the if let statement? The if let statement, right? Everybody sees what the mini is seeing here. Tanya, the third time, the first time we saw 1. Second time we saw 3. Third time we saw 1. We come inside of our for loop. Do we come inside the if let or we come inside the else? The if let is if we've seen that number already, right? Because if we come here and we go ahead, actually, if let, sorry. Yeah, you're correct. I'm sorry. Yeah, so if let is correct because we've seen 1 before. Everybody with me? Right? So we've seen 1 before. Tanya is correct. We come inside the if let. And what do we do inside the if let? Soren, what are we going to do inside the if let? What are we doing to count? We're going to add 1 to count, right? So let's access our dictionary here. We're accessing the key is number, and we say count plus 1. So whatever the count is, it adds 1 to count. Everybody with me? If count is 2, what is the current number? If count is 2, what will be the current number after that? 3, and so forth. So given an array, this is good, this is good. So here we come here if we've seen the number, and here that's the first time we saw the number. Okay? So we come in the if let. So visit, enter the let statement. If we have seen the number before. Cool. So this, I'll actually take that out because we just, I'll keep it. More notes, the better for review. This is the same thing, sorry. So using optional binding to unwrap the value at the given key, which we did here, in our frequency dictionary. Enter the if let. Enter the if let statement if we have seen the number before, right? And increment count by 1. Great. What did you do on number here? 1 second. So where the equal sign is here, you did plus equal, and you did this. Is that what you have? That error you got here? Is that the error you got? I'm trying to follow. Plus equal count, like this. That's what you had, right? And what's your error say? Well, something is an optional, right? It says value of optional integer must be unwrapped here. In that case, you can add, because this guy is an optional, right? That guy is an optional, and you're trying to add directly to the optional, right? In our case, we just assigned the value. That's the difference. You with me? If it was unwrapped already, it would be fine, right? In that case, it tells you to force unwrap it, right? Everybody with Jahid's observation. So he was trying to plus equal directly here, which is fine if the two types are the same. But here, the two types are not the same. This is an optional. You with me? And this here is a regular integer. Cool? So you could do it, but you'd have to bang it or nil coalescing it or something else. All right, so let's go back to what we had before. Great. Yes, sir?
I was just wondering the count.
The count.
If you're doing plus 1, normally that sounds like it's like current value of count.
Whatever the value is. If it's 1, 1 plus 1 is 2.
So wouldn't it, if it's going through a loop, be like a plus equals 1? Or what's the difference between plus equals 1 and plus 1 in that
Well, as we just noticed earlier, right? Jahid was trying to plus equal an optional to an integer, right? What we just had before, we had this plus equal to an integer, and that's not valid Swift code because you're trying to add an optional. Do you agree that this is an optional?
Yeah.
Right, so you can add an optional to a regular integer.
But I'm saying you're adding the one to
I'm adding the one to what I unwrapped. Every time I come inside the for loop, I'm looking at a different number.
well, I guess you're wrong.
Every time I come inside my for loop, I'm looking at a different number in the array. You with me? So whatever number I'm looking at in the current array, that's that number here. And it has the count as well, because the dictionary has its values already. Right? The first time I come, it doesn't have anything. First time I look at 1, it has 1 and the count is 1, correct? Next time I look at 1, my number is still 1. What's my value now? It's going to be 2. Right? I take out count and I add 1 to it. I put it back in the dictionary. Cool? That's good. Those are good questions. Like, I don't want to keep going if we have those questions. Yes?
My computer presumption because it's giving me a medicine that is an unresolved, a use of an unresolved identifier number.
It sounds like you're trying to use number and you're using it in the wrong. Do you have number in array here on line 12?
Or not, okay, so, okay. Or I can just change the number.
Cool? All right. Very good. 1, are you good?
So can I see the error? Can you do the put the equal sign after the one?
After
After
the
the plus, I mean. No, yeah, after the plus. So it's plus equals.
after this guy?
Yeah.
Well, that's not going to be valid anymore. You have 2 equal signs. That's not a valid statement. Right? What we're doing here, aside, is if the current count is 1. You with me?
Yes.
I say 1 plus 1 is what? 2. 2 is a value. I put 2 in the key. Yes. Cool? Very good. Very good. Like it. Any other questions?
I guess I'm still confused. We're saying because count is now a new variable that we're using.
Count is that unwrapped variable. Remember, we could have any name. It could be count of number. It could be any variable name.
I know, and it's saying that if the count is equal to that,
If it exists in the if-let statement, get me the count, get me the value. You're taking out the value from the dictionary, right? Give me your value. If your value is 2, I've seen you twice before. I want to say now I've seen you 3 times.
so take that number as you know,
Exactly, and put it back in the dictionary.
and then we're making that number back equal to count plus 1 because that's how it goes back to the dictionary.
Remember, the first step here is the count plus 1. Whatever value it is, 2 plus 3, 2 plus 1 is 3, right? Take that value, assign it to my key. Assign it to my key. If my key is 1, right, and coming in the second time, my count is 2. Now my key, the value for it is 2. Right? For example, up here, Tiffany, if I look at 7, I go through my entire array, I see 7 once. What's the count of 7? 1, right? If I look at 1, I go through my entire array. What is the count of 1? 4. So every time you visit it, if you've seen it before, you take it out, see its previous count, add 1 to it, and update that value. You with me?
Yeah,
Sure?
no, I understand that.
Okay.
I guess it's just the word itself. Let's just go on.
The word in itself is whatever count is, whatever the variable is, you gotta have a variable there in order to add it, right? Whatever that variable is, add 1 to it, increment. 1 plus 1 is 2, 2 plus 1 is 3. You with me?
Yeah.
Okay. And in our else statement, we simply say assign 1, because that's the first time we see it. Right? David? Right? The first time we see it, we just assign 1 to the key, correct? All right. And any consecutive time, we want to increment it by 1.
Okay, and when we had a previous dictionary and we had the array, that will only access the key.
The array is what we're going through to see how many times the key of the value appears.
The value itself is not.
The array has nothing to do with key. We're only going through the array to keep count of how many times we saw an element. We're going through the array just to see how many times we saw the element. It could have easily been a string. Go through the string and tell me how many times you saw A, or you saw the vowels, or how many vowels appear in a string. Cool? What do you want? Yes, sir.
My question with this is, where does it assign the key? That's what I'm curious.
Where does it assign the key? It's not assigning the key anywhere. Our array starts empty, right? And the assignment of the key happens when you say, if, that's why you assign the key the first time, here, on line 21, right? The first time you see 1, that gets created. That element gets created in our dictionary, right? It's like, just appears in our dictionary. The first time I see 1, for example, my dictionary now holds 1 element where the key is 1 and the value is 1. That only happens in our else statement. I come back, if I see 7, now my dictionary will have 2 elements, one with 7 where the count is 1, and a second one where the key is 1 and the value is 1. You see what I'm saying? So it only appends in, let's put that down here. So appending of an element in the dictionary happens here. Does that help you, Greg?
Yes.
Right? That's where it adds to the dictionary. That's where my elements in my dictionary goes from 0 to 1. Right? And every time I see a new element, it goes from 1 to 2 to 3, etc. Only when I visit the else statement. Yeah. And the if let increments the count. And the else adds an element to the dictionary. So, for example, first time, right? Our dictionary is empty. Do we agree? The first time we come to our array, our dictionary is empty. Right? Our dictionary is empty. The first time we saw 1, after leaving our else statement, our dictionary now appears like this. We have 1, 1. Right? First time we go into the loop for the array, our dictionary is empty. Everybody agree? When we go ahead and we do frequency dictionary number, assign it to 1, it becomes 1 element in our dictionary. Right? So first time here, and first time adding 1, adding the first element in the array, in that case. The first time adding the first element from the array. Our dictionary first time going inside the for loop, we have an empty dictionary. The first time we look at any element, our dictionary gets updated with that first element. Based on our array, the next time we come into our for loop, what's the next element here? Based on the array we have. Is it 3? So 3 gets what? What's the value of 3? 1. Everybody sees that? The third time we come into our for loop, what is the third element? How do I represent that here? Do I add the next element? Right, that's not valid, right? So I increment the count, correct? Right? Based on the code we wrote, right? It goes into the if let, count plus 1, put that back inside of my key. Yes, sir?
So, I guess my question would be, in the for loop, for num in array, would num always be the value?
The current value in the array, not the dictionary, right? That's a good clarification there. So Greg is saying, or to clear us up again, the for loop goes through the array, not the dictionary. The dictionary is used for storing. Everybody with me? Okay, so what's the fourth time? 1. What do we do? Brendan, what do we do to 1? Yeah, what happens to 1? If we agreed we're looking at 1 now, what happens?
So for the next, after the second one, it increments.
We did the second one already. I think now we're on the third one. So I don't want to go back and forth, right, up here. So here we're on the fourth one, right? Okay, so how does our dictionary update?
That updates the from 1 to 3.
Okay. Next person, Luba, what happens the fifth time we come into our array? We increment 3? Okay. What happens the next time after that? Anna? Everybody saw that? Anna says 4 now gets 1. So how many elements we have in our dictionary now? 3 elements, right? What happens next? Zara? 1 gets updated to 4. Okay. And it gets 1? Okay, next person. Who I haven't heard from? Maytree. Don't hide behind the computer. What is the next, what happens next? What element is that? 2. What's the value of 2? 1. This really, somebody's literally hiding. Oh, that's sorry, I called him already. All right. Oscar, what happens next? I increment what? I think we just looked at 2. What happens next? We're looking at our input array. After 2, what happens? Okay, what element is that? 7. What's the value of 7? 1. Very good. I think we have one more element, correct? Margaret? What happens next? 8. Oh, so it gets incremented here? After 7, what do we have? What happens to 8? So we have 8 already in our dictionary. What happens to 8? So what becomes the value? Value is 1. Okay, great. So value now is 2, correct? Very good. And at this point, we finished going through our array. Our dictionary is now populated with X amount of elements. And now we're done. Yes? If-let statement, the optional binding, right? This guy? Okay. So the only way to access, well, if we want to go ahead and add to our count, we want to unwrap our value in our dictionary, right? So here we're using the if-let statement to unwrap the value at that particular key in the dictionary. The current key we're looking at is number. Number is a key in our dictionary, or could be, maybe it doesn't exist, right? So we're going through our for loop for number in array. The first time we go into our for loop, what's number? That's the index. The first time we go into our for loop, what's number? 1. Does 1 exist in our dictionary right now? No. So do we come inside the if-let? Is there a value here? No. So where do we go? Else statement. And what do we do on line 28? We create first element, and first element, the key is 1, and the value is 1. So it looks like this guy down here. Well, before, it looks like 1. If-let is, if the value exists. If-let, going back to optionals. If the value exists, yes, exactly. If it exists, give me the count, and I want to increment that count. Cool? Very good. Any other questions? Again, really knowing how to do that problem is very, very important. If we do one thing for pair programming today, where you guys pair up together, is redoing this and talking about why why are you doing certain things and what's the expectation. Because again, it could be a valid interview question, especially like in a startup or whatever, where they don't have all day to look up a TSA question, they might just throw that at you. So knowing how to do it, same as like knowing how to reverse a string, never enter any interview not knowing how to do one of those. How to count something, how to keep count with something, using a frequency dictionary, where you have a dictionary that stores the value, right? And the count of it. Knowing how to do that, knowing how to reverse a dictionary without using that reverse. Those two things. Any other questions? Great. So let us move on to a question that I saw on Slack over the weekend from our optionals, not optional, from our closures. From our closures lab. It said write a function called largest value takes one parameter that finds the largest int in an array. Yes. Oh, we didn't? So much confidence. Okay, let's go ahead and print it out. Thank you. Nobody is stopping me here. All right, let's go ahead and call our, thank you, Steph. Tiffany. So we have, grab your array, copy the input array, and let's go ahead and call our function. We'll say results equal to, what do we call it? Occurrences of integer. Paste your array in there and go ahead and print results. Right? So results look something like this. We have 7, 1. Somebody stop me if we have an error. So 7 appears once, correct? Everybody? Does 7 appear once? 1 appears 4 times. Yes? 4 appears once, correct? 3 appears twice. 8 appears twice. And 2 appears once, correct? Right? Everybody with me? It's Monday, too early for sleeping time. Yes, we said that from the beginning. A dictionary is unordered, right? I could go through making it ordered, but that's out of the scope currently. We have a lot of stuff to do. But yes, you could make this ordered using like dot keys and going through the dot keys, but I'm not going to go through that currently. But now we got to our solution. Everybody with me? Okay. You could add more in there to test it yourself. But thank you, Tiff, for stopping us here. Yes, we got to see our results. Is the thing we just wrote, is it correct? I mean, we went through it many times to verify, but running the code is good. Okay, cool. So write a function called largest value that finds the largest int in an array of ints. And it said, use reduce to solve this problem. So use reduce to solve this exercise. We saw closures on Friday. It was good that we had a weekend to do it, because Friday to Friday would be too much on that one. Okay, so here, write a function called largest value. Great, so let's write a function called largest value. Whenever I'm writing my function, I like to start with the func keyword, give it a name, give it an empty parens, open, close my brackets, so I know I'm good. Everybody with me? Right? At this point, I know I'm good. I have a basic function. Then I'll go ahead, I'll go back and do the parameters, I'll do the return type, whatever else I need. Everybody with me? But the basic scaffolding is good, even when you whiteboard it, right? Okay, so largest value here takes in some parameter. What does it take in? An array of ints. So here we have in given to us. Remember, internal parameters, you could use any name you want. Everybody with me? Because it has in doesn't mean you don't have to have your own internal parameter name. I could have in numbers here, array, right? So internally, I'm not using in, which is a bit weird. Everybody with me? right? It's kind of awkward to use in. So have an internal parameter name. Here we're using numbers. Because in itself is like a keyword too. Yeah. So having an internal name is what you want. So numbers, what are we returning? What type are we returning? Integer. Everybody with that? Right? Because it says largest number, right? Largest int. It even told us. So here we're returning an integer. Great. Our function is pretty much getting ready to be done. So now, what's the next step? I could create some variable, call it result. I could return result to get rid of my compiler errors. Nobody likes to code with compiler errors, or nobody should be coding with compiler errors, right? Get in the practice of, if you see red, get rid of the red before you continue typing, right? You continue typing with that red, it's gonna get worse by the time we get to your computer. Everybody with me? You see red, stop on that first red, or the second red. But the fifth red, it gets really, right, it gets harder to debug. So as we see errors, get rid of the errors, continue typing. Okay, cool. So here we have result, and we are using reduce according to what the question was asking for. So here we have result equal to our array, it's called numbers. On numbers, we could use reduce. Everybody with me? Everybody with me? We saw reduce on Friday. So here we use reduce. What does reduce do? It combines the elements. It doesn't necessarily have to add all the elements together, but it sees all the elements. Everybody with me? If you see all the elements, it's up to you. Do I want to add the elements? If that's the question, you just add them. If the question is asking for something else, you want to do that something else. How can you achieve that something else? Well, you start out with having some parameter for the first parameter. It takes in some initial value. Here, our initial value will say 0, right? Our closure, remember, if you were to add all the elements in that array, this would be fine. Everybody with me? I take an initial value of 0, and I take some closure, in that case, the addition, right? And I add all of my elements together. You with me, Luba? So we add all the elements together, we get back some result. Great, but that's not what the question is asking. So if you want to go further inside your reduced closure, you could simply pass in, we saw that on Friday, where you could just pass in the parameter, and the last argument in reduce is a closure. If the last argument is a closure, what do? We use trailing closure syntax, right? We saw trailing closure syntax. So after the parameter, the closing parameter list, we could have our closure syntax. This here is trailing closure syntax, right? So this is my function call. Everybody agree? We called functions before. Reduce, I pass it 0. That's my function call. Everybody with me? My function has a closure as well, right? My function reduce has a closure. So Swift enables us to have what's known as trailing closure syntax, where you just pass in the closure that the function is expecting. See it as an argument. You pass in it an argument as well. But here, you have open curly and close curly. What's that? So let's look at reduce, right? So if you option click on reduce, or rather command click, jump to definition. I have too many errors right now. Let's go to the documentation. So if you go to reduce here, reduce Swift. Let's look at what the documentation looks like. Right? So here, reduce takes an initial value, right? In that case, we pass it 0. Let's look at the function definition. And the next partial result is a closure here, right? The closure is, the first parameter in the closure is the initial result, the initial value. And the second is the element that you're currently looking at. right? So that's the closure. I have two arguments. One is the initial result, and the next argument is a closure. So I'm able to use trailing closure syntax, right? So let's go back to what reduces. So here I will say initial value, which is fine. We said our closure takes how many arguments? 2, right? Based on the documentation. And my second, I could say current value or next value. I'm listening. Initial value, current value. Yeah, that could be. That's fine. Because that's the current value we have. Yeah, that's fine. So current value, right? Or current result, whatever you want to call it here. Okay. So again, looking at reduce again, we have 0, which is the initial value we pass in. We pass in 0. And we say, go ahead, expand on our closure, so we could do more in here. Because simply adding everything together is not enough. So we want to use trailing closure syntax here. Open curly, close curly. It expects 2 arguments. We pass in the first argument, whatever name you want. Pass in the second argument. And now we want to do some sort of comparison, right? Basically, we're looking for the largest value. So as we're looking at values, is the previous value larger than the current value? If the previous value is larger than the current value, we want to keep the previous value. Everybody with me? If I'm looking at 0, previous to 0 was 5, I want to keep 5. So I want to return that to the result. So that's basically what we need to write here. So I'll do it the long way. So if current value is more than next value, return current value. Else, return next value. Right? So what it says here, if the current value I'm looking at is 0, in that case it's 0. If 0 is more than next value, then just return 0. But if that's false, return the next value in our array, whatever our array has. So here in our closure, we could do more work. In the trailing closure, we could do more work. As opposed to simply having a closure, I'll just make an example here, where we have numbers dot reduce 0 and 1, for example. Or it could be multiplication, doesn't have to be addition. If the question asks, go ahead, return me the product of every integer, or return me the product of the integer combined. So then you would multiply the first integer times the second, and so forth. But in that particular question, we need to do more work in the closure. How do we do more work? We go ahead and we open our curly, we close our curly, and we write the logic needed to solve the problem. Right? Here we need to write more logic to figure out, is that current number larger than the next value? So in our closures, any closure, you could do more. In sorted, you could do more. In filter, you could do more than simply saying $0 is more than 5. Right? If you have to do some extra logic to sort your array or whatever, you have to go in sorted closure, trailing closure here. So here we're using trailing closure, using trailing closure syntax to solve this. Right? Questions about what we did here? Yes, sir.
So if all the numbers in the array were negative, you would just change the results and put it like that?
if all the numbers in the array were negative. Doesn't,
Want to return 0?
oh, in that case, our 0 here. You could
Well, I mean, for our result.
You could get the first element if you want. Let's actually do that, and we look at guard. I like what you're thinking. Okay, so instead of saying 0 here, right? Question? Yeah, I'll go through it, yeah. I'll go through it again, but I'm going to make it more complex now, since Mr. Kelby wanted to guard. So I want to show us guard, right? Guard is a very great tool to unwrap optionals. We haven't formally seen guard yet, because we're still trying to wrap our head around iflet, right? But here, let's see what guard looks like. I basically want to get the first element in my array. If I go ahead and say my first element in my array, numbers, at 0, that's fine. What happens if my array is empty? It crashes, right? Who said that? Right, so Christian says it crashes. Do we see that? If there's no elements in my array, I try to access 0, it crashes, index out of bounds. Doesn't exist. Right? So using guard, so we all agree it crashes, right? If we're not, I could go over it. I could show how it crashes, if we're not sure. Okay, so here we could say I want to get the first element in my array. So let's go ahead and say using guard to get the first element in the array, right? So here I'll start out with the keyword guard, guard. Guard is the next way of unwrapping optionals. We saw iflet, we'll see whilelet a bit later, right? We saw nil coalescing. Guard here, we'll use guard and say guard numbers dot count or is empty. I'll use dot count here. Is more than 0. Else, we have to use an else with guard. So guard some condition, right? Guard against some condition. I'm guarding that numbers dot count has to be greater than 0. That's what I'm guarding. I'm putting a guard here. I'm saying, hey, look at this array. The only way you continue if the count is greater than 0. Basically, guard is like saying if this condition, but it has some more powerful properties on it. We'll see later. So here, guard numbers.count is greater than 0. Else, you need to have a return here. Else return -1, for example. We'll just return -1. Okay, so now this guards against my count. You could put a comment here. So this is guarding against an empty array. Using guard to ensure an array is not empty. And the second guard we'll use is using guard to get the first element. So we saw guard once. Let's see guard again. So here, guard let first equal to. So here we're using guard with let. Very similar to if let, right? Very, very similar to if let. So guard let first. My array is called numbers. On numbers, we have a property called first. That gets us the first element in the array. So here we need to have an else statement as well. So else return -1 again. But now it's different. We have access to first here, right? Different than if let. If let, you only have access to the variable inside the if let. Everybody with me? In an if let statement, I only have access to that variable called first inside the if let statement. But with the guard, I have access to first throughout my function. In an if-let statement, let me show you. So if-let first, for example, equal to numbers dot first. Right? Do I have access to first in the else statement? Sarah, do you have the code we just typed in? Okay. Do we have access to the first inside the else statement? The first from the if-let? Inside the else statement, do we have access to first? Not from the guard. If I was to comment this out, right? If I was to comment this out, Eddie's saying we have access to first here, right? That's very important, right? Use of unresolved identifier. We all need to understand that before we continue. Our if-let, we only have access to first on line 52. Everybody with me? Eric. I unwrap the value. I only have access to it inside of the if-let block. Right? So first here only has access to first inside. So that's a, if you see that on the coding exercise, only has access to first inside if-let statement. So it does not compile. If you see this code for the job, does not compile. We unwrap our numbers at first. We put it in this temporary variable called first. We have access to it here. Everybody with me? You need to type that out to understand what's happening. So I unwrap my variable called numbers.first. It's an optional. If it has a value, if there is a value in the array, go ahead, assign it to my first variable, and now I have access to it on line 52. Everybody with me? So if I say like just print first, that works, right? So print first here, right? No compiler error. But if I want to go ahead and use it in the else statement, do I have access to it? No, I don't. I do not have access to it. So it does not compile. Exactly, exactly. Very good. So first is just a property on arrays that gets you the first element in the collection, if it exists. Exactly. So that's the best way to do it as opposed to saying index 0. There's no guarantee there's elements in there. Our application will crash. Yes, sir. Any collection. Okay? Any collection has, remember, we spoke about protocols briefly. Any collection, meaning you could do for loops on it, has a dot first. Okay? All right, so here, great. So now we know. That's good. So the context for the guard gets clearer by having that if-let, because if-let is not enough. Yes, you could say, oh, I could create a next variable. Sure, you can. You could create a variable called first or whatever, have access to it, right? But by its nature, if-let, you only have access to that variable, that unwrapped variable, inside the if-let. Cool? Cool? Kelby? All right. All right, so should we leave that or just comment it out? We're not using the if-let in that case. I just wanted to show you guys what's the difference. So maybe just comment it out so we're not kind of distracted here. Okay, let's go back to our if-let here. Our guard. With guard, you have access to first down here. On 57, I could say first here. It starts to autocomplete. Do we see it? Start typing first and you have access to it, right? The guard statement is that powerful. Guard the thing. If it exists, put it in this variable. Now I have access to it anywhere in that scope. Anywhere after the guard, I have access to first. Right? So the quicker we get used to using guards in functions, the better our lives will be as far as like not creating extra variables to hold stuff. I guard against something, I know it exists, put it in this variable, use it. Yes, sir? Does guard allow you to call? The guard is just used for unwrapping an optional. Yeah. You unwrap the optional, you have access to the variable anywhere after that guard, inside that function. Not outside the function, that's outside scope. Yeah. So outside the scope, I'm not sure today, but at some point we'll see in-out functions where you have a reference. I think we'll do it after classes. That'll give you guys better context. I don't want to show that now because I'll talk about references. We haven't seen classes. It just becomes more things like, right? Cool? So guard, we have access to that variable inside the scope of that function. Yes, sir?
It seems like a more powerful way to
It is way more powerful.
Should we ever use it like without?
You will. There's use cases for both of them. Yeah. Like there's use cases where you only want to have the thing in the scope of the if-let, have an else on it. Yeah. Cool? And then keep in mind, I'm not going to do it now, but keep in mind, as we did if-let, comma, more optional binding, everybody, I could guard against multiple variables with commas. I'm not going to do it now, but it's possible. And we'll see more of it as we go deeper into the course. So now we have our first. That was a bit of a tangent there, but it's very good tangent. We saw guard, we saw if-let scope. Now we'll just use first here instead of 0. That was the whole wraparound because the question came up, if we have a negative number, who said that? Right? Kirby was asking about a negative number. Now we know for sure the first here exists in our array. Everybody with me? Because 0, what if you have a negative number or whatever the case may be? But here we guarantee that first is an element in our array. So is that first number the largest in the array? Everybody with me? That's a very good place to start. That's defensive programming right there. So now, any questions before we move on? Again, guard will get a bit getting used to, but it gives us the power of if-let plus some more. The plus some more is we have access to that variable in the scope of the function.
So in that case, would -1 be the default in every array?
Ideally, that function should be like optional, but I don't want to change it for now. But it would be better being an optional. Yeah, very similar. Right? If that was an optional, it would be better. I just return nil here. You see what I'm saying? Like, there's nothing. It didn't exist. Yeah. Or you could just do a fatal error. There's a lot of things I'll show you guys later, but for now, just -1. Okay? All right, everybody? Okay. So moving on, we have our first here. Great. And we said, do we understand what's happening here? 60 to 64. 59. The whole syntax. Okay. So remember we said reduce could give us, let me go back to the add symbol here. Remember we used reduce in that way on Friday with the comments, right? We said, hey, I want to go ahead and add all the elements in an array, right? I start out with 0. It's a good place to start to add. Cool? And we added everything. And we said that add here is a closure as well, right? It takes 2 values, it returns some integer. That's a closure by definition. I take in 2 values, I return an integer. Add does that. It takes in 2 elements, it returns based on our closure here. Cool? But what if you have a more complex thing to do with numbers? Right? What if, in our case here, what if beyond just adding or looking at numbers, you have to figure out is the previous number larger than the current number? How do you do that? Right? Based on 66, this is not enough. You cannot solve that problem with that, right? You'll do either adding or whatever, you don't want to combine them together, right? The only thing you want to do is return, right? Remember the reduce returns an integer in our case, right? Our reduce works on an array, so by definition of the closure, it should return the element, one of those elements in that collection. By definition, that's what reduce does. If given an array of strings, I expect my output to be what? That's where we should clear it up. So reduce takes in a collection. Our collection happens to be a collection of integers, right? But the output needs to be an integer. What's that? After. Yeah, go ahead. Of a collection of strings, an array of strings. Yeah, an array of strings. It would be a string. Yeah, because think about it. If you have an array of strings, you want to combine them together. What is the result? Everybody has to. Do we have to? We have to clear that up. Reduce takes a collection of elements, combines those elements together. In our situation, we've seen two situations before. Both of them happen to be integers, right? But in an interview, ask if what reduce returns, int is not the correct response, right? It could be a string. Whatever that thing you combine in, that data type is that data type. If it's an array of, again, like your of IDs and your type is ID, it returns an ID. It combines all the IDs together. Everybody with me? Okay, cool. Now with that said, our reduce takes one step further. Reduce goes through each element. Everybody with me? It goes through each element, and based on the closure you provided, it will combine those elements. Right? Not necessarily combine them, but it will combine them given an add or multiplication, whatever. But in our case, we want to look at every element, but just return, not the full result, but return the larger integer. Right? Yes? So in every situation in the reduce, you have like a previous result. Think about it like a previous result, and you have the current element you're looking at. We don't want to combine them, exactly. Or what we want to do is, hey, if we start out with 0, keep that element, and the current element we're looking at is 2, right? If 0 is larger than 2, return 0. But in that case, it's not, correct? So we have to return 2. We don't add them together. The thing we return in, we still return in an integer, but we're not adding 0 plus 2. You see that? It will return 15 if there's two 15s in the array. No, it's not going to return for 30. No, it just returns whatever that element is. Even if there's three 15s and that's the largest, it's going to return 15. It won't add them together. In that particular question, we're not adding anything together. That's the thing that might lost us a little bit. Reduce doesn't necessarily have to add the elements together. Everybody with me? Everybody with me? Yes? The previous result? Yeah, okay. Yeah, right. Let's go to the array. Does that help? Let's go to the array and talk about it. Actually, we don't have an array. Yes. We're comparing it. What line number? Okay, so remember our reduce takes two arguments. The first one is like the previous result or whatever. The next one is the current value you're looking at. Cool? So looking at those two values, is my previous larger than my current? Right? In that case, you want to return if the current is larger. Right? Else, just return the next value. But you're not adding. Right? We could have simply been adding here and just return current plus whatever, next value. That would be like what we did on Friday. But that's not what we want. We just want to return the largest value. Cool? Oh, this curly, sorry. Yeah, that's the closure. Instead of the add, that is our closure. Everybody on that one? Maytree? Right? So the open curly and the closed curly is our plus if we are doing plus. That's the closure. Right? Cool? Okay, so I think we were doing one more example, then we'll break. So here we have 0, and then we have a more complex closure, for example, like this. Let us make that a little better. So if we have a more complex closure, like that guy, we would want to expand it. Right, so that's the difference here. And here, you could have previous value or previous result, probably rename that up there too. Here, just think about it like the current value you're looking at. Let's actually update those because I don't like necessarily those names. So this is previous result. This is current value. Yeah, so if previous result is greater than current, return previous, and here let's return current. Good. Okay, so our reduce takes in a previous result. In our case, it's 0. And the current value is that value we're looking at, right? So you could become more complex using a closure like that. So step 1, simple, right? Straight to the point, add everything in the collection. That's step 1 here, or not step 1, but what do we want to say? I'll just put 1 and 2 for now. So in 1, simple reduce, you have an initial value, which is 0, and you have a closure here, which is add. Add everything together, right? Our closure could also be division. It could be multiplication, whatever that adds two integers together. Everybody with me? Step 2, you have a more complex problem like the one we have. You have to go ahead and expand on your closure here. Go from step 1 and use trailing closure here. So step 2 is using trailing closure syntax. Our function takes in 2 arguments. First argument is, in that case, an integer. Second argument is a closure. If your function takes a closure, the second argument, you could use trailing closure syntax. That's the 2 differences that we need to revise. And we could keep revising it through lab today. Somebody could come around and help us figure out exactly what's happening there. But that's what's happening at a high level, right? Same you could do with sorted, filter, anything. Right? You could expand on the closure. Questions? Print. Yes, that's what I'm going to right now because Tiffany is looking at it. We didn't print yet. Okay, so let's see. Do we have an array? What do we have?
Go up from this, yeah, because there's so many comments that.
Well, this guy is not part of it, right? We agree?
So
43 is not part of this. All right, what do you want to do? Test first or we go through the thing first?
no, let's go through.
Okay, so result is part of it, sorry.
It is fun.
Yeah, but it's not what you think it is. Result should be, let's do result right after this guy. Let's do result right here. Great. Cool? You want to test it first or you want to go over it first?
I would go over.
Okay, so let's go over it. Let me see if I can get this smaller so you can see everything on one screen.
The function is largest result in numbers.
Okay, the function name is largest value. It takes in an array of numbers. It needs to return the largest integer. We use guard to get the first value in the array. Tiff, we use guard to get the first value in the array, right? We got the first value in our using guard, right? Guard, after guard statement, we have access to the first variable, right? So far, so good. We use iflet just to show us the context between guard and iflet, right? Moving on here, let's make this a let. We use numbers array. We use numbers array. Dot reduce, right? To go through every element of that array. You with me? So reduce here, go through every element of the array. It could combine them very easily, but we are not combining them. Right? We are not combining them. Simply what we're doing is looking at the previous result. If previous result is greater than the current value, return the previous result. If previous result is 5, current value is 2, what do we return? What number? 5. If it's not, what do we return in that case? If 5, well, if 2, yeah. Exactly. And that's it. And at the end, we assign result, whatever the final value is, after we've gotten to that last element. After we've gone to the last element, our previous result, or whatever we returned, goes into result. It's moving, it goes linearly, exactly. That's the only way it could add, if you want to add. It goes through each element, it just happens to be adding them together. That's the closure you gave it, it adds them together. But in our case, we do not add them together. Our closure doesn't add. Our closure just inspects.
You said that first equal to numbers, the first.
First equal to
So when we
numbers.
say reduce first, what exactly is that saying?
Reduce first is basically our variable. Remember, our variable is just a variable.
Right.
That's just a variable. And I'm using that first number as my initial value.
Right.
That first there is the where I begin to look.
Right.
I begin to look with my first element.
Right.
After that, that element becomes, if I'm looking at 2 as the first one, and I come across 5, it becomes 5.
Okay.
And then I keep going until I get something larger than 5. If not, 5 is returned.
Fine.
Yeah. And cool, so let's test it out.
When it says one down first, as we roll through the element,
That changes.
the largest number to be the first.
Yes, exactly. So that changes. Very good. And let's test it out. It is.
And we still leave it as a let, even though the result itself.
Yeah, result itself doesn't change.
Result doesn't change.
No, result doesn't change. That's what we return at the end. Yeah. So let us print out our thing here, largest value. So go ahead and print largest value equal to largest value in, let's just create some stuff here, 56, 100, minus 56, 0, and 207. Okay, based on this, what is the largest value? Wait, 1 second. What am I doing? Variable used within its own. Oh, largest result, sorry. And then print largest result. Okay, what's the largest result here? 208. So let's run the code and we get 208. Right, everybody? So basically that first here that we were looking at is that initial value. Reduce, you have to give it an initial value. Let me go back to it. This first here, everybody, we happen to get the first element in the array. Okay? And we keep comparing, does that first element, is it the largest one? As we go into each element in the array. Reduce, as filter, all of those higher order functions, they go through every element. Right? They have to go through every element to see what you're looking for. If it's filter, for map, you want to map, transform something, it always goes linearly through every element. Reduce does the same thing, but it happens to add if you want to add, or multiply, or subtract. In our case, we're going through every element, but we're not combining them together. Right? I mean, literally, filter would be the best for this. Right, everybody? Right? The question is just forcing you to use reduce and really understand how it works at the end of the day. Filter, reduce wouldn't be the best solution for this problem. What? Filter, you get the largest one. Yeah, largest, whatever the thing is. And then if it's return the first one. But reduce wouldn't be the best case there. But I like that problem because it forces you to know how reduce works. Do you have to combine them? No. But I'm looking at all of them. If I want to combine them, great. I could combine them with anything I want if I do want to combine them. But in that particular case, I'm only looking at the elements and returning the largest one. So your closure by nature, whatever you return is up to you. You just have to return the correct data type. We have to return an integer here. But how we transform that integer is up to us. We could say integer 1 times integer 2, return integer. We could say divide by integer. Anything that transforms those integers, those two integers, to one integer is valid. Cool? All right, so trailing.
The trailing closure syntax is just the open brackets
Yeah, this guy, number 2. The open curly bracket, close curly bracket.
And that's always the syntax for trailing.
Yeah, for trailing, yes. But you have to know how many arguments it takes, right?
Right.
Right. Yeah,
And
yeah.
it could be more than two.
It could be more than 2, it could be 0,
Okay.
it could be 3. So you have to look at the definition of that particular function you're using. It will let you know too. The compiler is pretty good at letting you know. Like, hey, expected 2 arguments, only passed in 1. With that particular, it's very good, the compiler. But knowing how to go from number 1 to number 2 is very important. Everybody with me? Everybody with me? Okay, cool. So we will stop there.